how to solve implicit differentiation. That is to say, in this question, we're going to focus on the question called implicit function. We're going to solve this question implicitly because in implicit function, once we differentiate x, assuming you have y is equals to 2x squared, then if you differentiate this function with respect to x, then it will be dy dx is equals to 4x. But in the case of implicit function, x is attached to y, therefore we're going to solve this one simultaneously. That is called implicit function because we are going to apply both product rule and theorem. Okay, in case if you differentiate y, you are going to multiply with dy dx or y prime or f of x. Once we differentiate the function that containing y, you must multiply with either y prime f of x dy dx. But once you differentiate the function containing x, no need for multiplying with this dy dx or y prime or f of x because they all mean the same. Okay, let's go there. In the first case here, we have 2x. Let's write solution. We have 2x squared y plus 3y plus 2x cubed y squared is equals to 14x. Okay, the first case here, you are going to say once you differentiate x together with y, then you can keep y constant. Later on, you can differentiate the x. Okay, then you can say here you have 2 times 4, here you have 4xy. Because this function we differentiate with respect to x, no need for multiplying with dy dx or y prime. Okay, then next thing to do, we can say plus. Later on, now we are going to differentiate y. If you differentiate y or x, once you differentiate x or y, that is the cost, this one will be 1. Unlike the constant time, if you differentiate 2, it will be 0 or any number. But when you differentiate x or y, it will be 1. Okay, now if you differentiate y, it will be, if you differentiate y, it will be 1. Therefore, you have to multiply with dy dx or y prime. Let's multiply with dy dx plus. Then this is, again, you have 3y only. There is no x here. It doesn't contain x. Therefore, now we are going to say, if you differentiate 3y, you are going to have 3 dy all over dx. Then in the next case, now we have 2x cubed y square. Then now you can differentiate with respect to x before the y. You have 3 times 2. We have 6x squared y squared plus. In the next thing to do, we are going to differentiate the function. We are going to keep 2x cubed constant and differentiate y. Okay, in this case, there is something to consider here. Here you are going to, since you differentiate with respect to x, for the y you are going to multiply these 2 with these 2. Therefore, you are going to have 4x cubed. If you differentiate y here, you can have only y here. Because this y, if you subtract 1, it will be y only. You have only y raised power 1. Therefore, if you multiply this with dy all over dx, this is equals to 14x. Okay, that is the first step Now we are going to collect the like terms, not that containing dy dx. We are going to collect in one place. Therefore, we have 2x squared dy all over dx. We have plus 3 dy all over dx. We have plus 4x cubed y dy all over dx. This is said to say plus the one that contains x and y, x or x and y only. We have 4xy plus, then we have 6x square y square. That's all. Is equals to 14. Now if you differentiate 14, it's supposed to be 14x. If you differentiate 14x, it will be 14. Okay, now we have only 14 here. Then in the next case, we are going to factorize those that having dy all over dx. Therefore, we have dy all over dx, open bracket, we have 2x squared plus 3 plus 4x cubed y close bracket plus 4x y, that is 4x y is there, plus 6x square y square is equals to 14. Then in the next case, you are going to carry out those that doesn't contain dy dx into the right hand side. By taking from here to here to the right hand side, they will contain minus. Therefore, you can have dy all over dx. You have open bracket 2x square plus 3 plus 4x cubed y plus 4x cubed y, that is equals to, the 14 is already there, that is to say you can say plus. That is, if you take this one to the right hand side, it will come with minus 4xy minus 6x square y square. Now we are going to divide both sides by the coefficient of dy all over dx. Okay, then we can say we divide both sides by 2x square plus 3 plus 4x cubed y. Therefore, here we can divide both sides also with 2x square plus 3 plus 4x cubed y. Therefore, this one will cancel out this one. Then remain dy dx is equals to 14 minus 4xy minus 6x square y square all over 2x square plus 3 plus 4x cubed y. If you wish, you can factorize the numerator and leave the denominator, or we can say dy all over dx is equals to, then we can factorize the upper one, that is the numerator, because 2 can enter 14, 4 and 6. Let's use 2 outside. 2 open bracket 7 minus 4 minus 2x y minus 3 x square y square all over 2x square plus 3 plus 4x cubed y. Then that is our solution. Don't forget to like, share and subscribe our channel. Thanks for watching. Bye.